This is class 11th Computer Science, Unit 1 Computer Fundamentals, and we are taking the Chapter 1 Computer Fundamentals. In this chapter, we'll learn about the evolution of computers, various generation, and the basic operation of computer we'd like to know. Then what are the components which make a computer and what are their interconnections? This also we'll study. Then what is booting, and then we will try to classify the computers. First thing is, computers now are everywhere. In our life, they are indispensable now. Even the mobile, the smartphone in your hand is a short form of your computer. You want to book a ticket, you want to do some weather forecasting, some friendship, social networking, any purchasing, anything, computers are now indispensable. So it has revolutionized our lives, and the accuracy and the speed which this computer gives is truly unmatched and remarkable. There is no organization now, that will not have a computer. Few may have, but few may not have. But now it is now an essential part. This is not just a luxury, it's an essential part, because computers have many benefits. Right from the day or days where it was simple calculating device, now we have portable high-speed computers at our disposal. The evolution of computers, the growth of these computers is from the days where it was to calculate things. Even the calculation was not done. So it all started with that. Why we need computer? Because the manual working is prone to errors and it is quite slow. Then the calculators were made more faster, some memory was added, and it started with, if you might have played when you were a child, calculating device which is called as abacus. And this was the device which we today also see, and it used to calculate. And then there are various generations we are going to see. So this was abacus. Let us see what happened or how everything started. This was discovered by Mesopotamians in around 3000 BC, and this abacus, as you see in this figure, it consisted of beads. These are beads, and these are rods, movable rods, divided into two parts, first part, second part. So the addition and multiplication of numbers can be done by using the place values of the digits of the numbers and the position beads in an abacus. See, these are the position 1, 3, 5, 2, 9, 6, 4, 7, 0, 9, 0, 8. From 0 to 9, that is 10 numbers are there. The Chinese then further improved this abacus. Even today, the young children, they use it for calculation. Each row is thought of as tens place, and from right to left, row number 1, this represents one column, and second column represents tens place, the third 100 place, and so on and so forth. So the starting position of the top beads, representing the value of 5, is always towards the top wall of the abacus, while the lower beads, which represent the value of 1, will always be pushed towards the lower wall at a starting position. Now Napier's logs and bones, as you can see here, the idea of logarithm, log E, log 10, was developed by John Napier. So he devised these numbering rods. We also call it as Napier's bone, through which multiplication and division can be performed. So these were numbered rod which can perform multiplication of any number by a number in the range of 2 to 9. So there are 10 bones corresponding to the 0 to 9, And there is also special 11th bone, which is the multiplier. And by placing bones corresponding to the multiplier on the left side, the bones which are corresponding to the digits of the multiplicand on the right, the product of two numbers can be easily obtained. Then Pascaline. Blaise Pascal, this is the Pascaline. He was a French mathematician. He invented an adding machine in 1642, and it consists of gears so that the numbers can be added quickly. This was Pascaline and was able to add and subtract. Along with it also has one more capability, the carry transfer. If we add 9 with 2, 9 plus 2 is 11, 1. 1 will be carried if the numbers are here. So this carry capability or carry transfer capability was also there. And it worked on the clock principle. So it consists of various number toothed. These are toothed wheel having their unique positions. And the addition and subtraction operation are performed by the controlled rotation of these wheels. Leibniz's calculator in 1673. Leibniz, he was a German mathematician. He added certain capabilities to Pascal to add the multiplication as well as the division. So the multiplication was being carried out through repeated addition of numbers using a stepped cylinder, each with 9 teeth of varying lengths. Jacquard's loom. Now this was the, I can say, a paradigm shift. How it happened? Mr. Joseph Jacquard, in order to make his cotton weaving process automated or automatic, he devised punched cards, and then he tried to control these looms in 1801, and everything was program control. This was an historic invention, and it has concept of storing, also retrieving information. Then we had the father of computer, Charles Babbage. He was an English mathematician. He developed a machine called difference engine. This was able to calculate various mathematical functions. Also do the polynomial evaluation by finite difference, and also theoretically, not practically, but theoretically, it can also solve differential equation. This is your differential engine. And in 1833 thereafter, he designed an analytical engine, and this was the basis of the modern computer. So this machine can perform all the 4 arithmetic operations, plus, minus, division, multiplication, and it also has a central processor, memory storage, and input-output devices concept. Even the stored information now can be modified. This analytical engine was never built, but the basic principle which Charles Babbage has established, today's modern computers, they work on this only. This is why he is the father of modern computers, Sir Charles Babbage. Mark 1. In 1944, Professor Howard Aiken, he collaborated with IBM. IBM we already know. This company is a giant in making all kind of computer equipments. IBM constructed an electromechanical computer. He named it as Mark 1. Now it can multiply 10-digit number in 5 seconds. And this was truly based on Babbage analytical engine. And it was the first operational general purpose computer which could execute certain instructions which were pre-programmed without any human intervention. In 1945, Dr. John von Neumann, he proposed a concept for stored program computer. And according to the concept, the program and data could be stored in the same storage memory unit. And the basic architecture of this von Neumann computer is like this. Processor, there is a communication channel, you have program and data in the same storage. This is von Neumann architecture. We also have Howard architecture, etc. According to this architecture, von Neumann architecture, the processor executes instructions which are stored in the memory. And because there was only one communication channel, the processor at once or at a time, it can either fetch data or an instruction. So instruction are the instruction or the orders which are given for certain data to be fetched and the execution can be done or a operation can be performed. So at one time either the data can be picked or the instruction can be taken up. So it was sequential in nature, and this limitation actually was called as von Neumann bottleneck. We will not talk about this bottleneck. Actually this gave birth to various new inventions, but what he made is incomparable. It was delightful. It is which we are using now. EDVAC, electronic discrete variable automatic computer. This was the first stored program computer developed in 1952. And after the invention of first electronic computer, ENIAC, electronic numerical integrator and calculator, in 1946, the computer technology, it took an exponential growth and it went very fast, at very fast pace. Now we'll see the generation of computers. How this generation has come? This generation is characterized by some hardware or software development that has given a paradigm shift, or you can say it has given an immense improvement in the performance of the computer. And based on these stages, computer can be divided into different generations. We'll talk about these generations now. First generation 1942 to 1955. The first generation computer used the concept of store program, and these were characterized by the vacuum tubes. So vacuum tubes were actually delicate glass device that can actually control and also amplify the electronic signals. So though this first generation computer were made using thousands and thousands of vacuum tubes, and at that time they were the fastest calculating devices. These were very large in size, consumed a lot of electricity, a lot of heat they produced. So UNIVAC 1 is the first electronic computer of this generation and was used for business applications. So the salient feature of first generation computers, they used vacuum tubes to control and amplify electronic signal, and they were very huge. They occupy a lot of space. The electricity consumption is quite high and the heat generation was immense. Because the hardware technology was not that developed, so it was quite unreliable. And the commercial production was quite difficult, very costly, and it needs to have constant maintenance. Air conditioning was required. And the programming was done in machine language. By the end of this generation, assembly language has also come. So ENIAC, EDVAC, UNIVAC 1, these are all the first generation computer. In fact, ENIAC weighted 27 tons. The size was 8 by 100 into 3 feet and consumed around 150 watts of power. Then came the second generation, 1955 to 1964. Now, the second generation computer, it is characterized by transistor. So this transistor is a solid state semiconductor device in the electronic industry. These transistors were very small, quite reliable. They consumed less electricity and the heat generation was also less. Also, the magnetic core memories were also developed during this generation. And these magnetic core memories were actually tiny ferrite rings like this. And this can be either clockwise or anti-clockwise direction, they can be magnetized, and the binary 1 and 0 can be stored here. And these magnetic cores were the primary memories. Then the magnetic disk came into existence, and they were called as secondary storage device. So these developments like transistor, magnetic core memory, and magnetic disk storage, this made the computer more powerful and more reliable. Then the existence of operating system also came into existence, and the languages Fortran, COBOL, ALGOL, they were also developed. The computer was used for commercial application, for business industries like small application, payroll, employee management, inventory control. So IBM 1401, IBM 1620, these are the popular computers of the second generation. The salient feature of second generation: transistor based technology, smaller, less expensive compared to the first generation, less electricity, less heat, magnetic core memories and magnetic disk. These were primary, these were secondary. First operating system OS was developed, and the programming in assembly language and later part high level language, which we just discussed, were used. And the commercial application of this started, but the production was quite difficult at that time also. And it also required constant air conditioning. All these are examples of second generation computer. Then the third generation. In 1964, ICs, integrated circuit. This again revolutionized the electronic industry. Actually, computer is what? Computer is an electronic device. So whatever changes are there in electronic industry, it directly affects the computer. So the electronic industry, it started the third generation because of ICs. So ICs, they are very small silicon chip or wafer made of extremely purified silicon crystals. So it has numerous transistors, capacitors and resistors on an electronic circuit. The SSI and MSI, this SSI small scale integration chip, they used to have about 10 transistors on a single chip. MSI 100 transistors on a single chip, 100. The size of memories also increased, and various mainframe and mini computers were developed during this generation. The operating system, which started in second generation, now enhanced to multitasking and multi-programming features. We'll see about this. The ICs were very reliable, very inexpensive, faster, and they were used, the computer were used in the areas of education, small businesses and offices, along with their industrial and business application. So IBM 360, Honeywell 6000 series, these are all third generation computer, and the salient feature of third generation computer is they used IC, integrated circuits. The computers were smaller, faster and more reliable, and the power consumption was low and the heat was less. Then we came to fourth generation, 1975 onwards. In this generation, LSI, large scale integration, VLSI, very large scale integration, around 300,000, 3 lakh transistors were used on a single chip. So the integration on a single chip of a CPU was achieved in 1971, and this was named as microprocessor, which actually marked the fourth generation. The computer based on this microprocessor technology were very fast. The speeds were immense, and also the memory capacity were increased. They were efficient operating systems, and the microprogramming, the application software, databases, virtual memory, these all concepts were in fourth generation. The computers today we have mostly are of this generation. Also the portable computer. Memory sizes have decreased, and commercial production is quite easy, quite least expensive if you compare it with the previous generation. Then the salient feature of this generation was ICs with LSI and VLSI, microprocessors were developed, the portable computers were developed, and also the networking and data communication, it became popular because this computer along with networking and data communication we see today. Various types of secondary memory and high storage capacity and fast access were developed. The computer became very reliable, powerful, and small in size, and the consumption power was less, and the heat generation was also less, and the production cost became very less. Then the fifth generation computer, these are still under development. So these are based on the AI, means artificial intelligence. We want computer to act and work and behave like a human. So this would involve the principle of parallel processing, superconductivity, so that they can understand human language. They can use the experiences which a human being have and take or make decision on their own. Like voice recognition, visual recognition, these are all the steps. We already have various products like the automated car, self-driving cars, various things which are you will see and learn in fifth generation computer. So the parallel processing, superconductivity, and artificial intelligence, these are the salient feature of the fifth generation computer. So the computer, then data and information. We'll talk about this because from here we'll actually go into inside the computer, and then we'll see the functional components of a computer. So let us stop here for now, and we'll take the next part shortly. Till then, thank you so much. Take care of yourself.